Aerobic adaptations. This section I will now move on to discuss the aerobic adaptations that can occur on our bodily systems after consistent aerobic training over a long period of time, from 2 to 3 months. This section will explain these adaptations that occur on the different systems due to this particular method of training and why these adaptations will occur. Firstly, overall endurance adaptation requirements. The overall aim of aerobic exercise adaptations is to increase VO2 max. VO2 max is the maximum volume of oxygen your bodily systems can use during exercise per minute. Therefore, improving VO2 max would mean that your body is more efficient in using oxygen and would be in this type of exercise very effective, improving all types of aerobic training. For example, if a marathon runner were to increase their VO2 max, then this would mean that they could consistently provide more oxygenated blood to the working muscles and the heart, and therefore would be able to sustain a greater speed throughout the event, as well as being able to run and fuel themselves for longer, due to the fact that when using oxygen, our body is able to use fat stores to provide energy, which is our most efficient store of energy, and doing this is also stored in our body in a large abundance, which in comparison to carbohydrates is very useful. Increasing VO2 max would also benefit aerobic athletes and games players, as this would mean more efficient gaseous exchange would be taking place due to the increase in volume of oxygen, and therefore cause CO2 to be successfully expelled from the body at a better and faster rate, meaning a person will be able to exercise in this way for longer, as there would be a less sufficient build-up of this harmful waste product. In terms of a games player such as a footballer, gaining the aerobic adaptation of increased VO2 max would mean they are able to run for longer and at a faster rate, and therefore have a higher work rate during a game, which would overall cause massive improvements in their overall game on and off the ball. Both examples of VO2 max for a footballer and a marathon runner would be working at different intensities. However, still when both of these sports are working aerobically, this aerobic adaptation would cause them to both massively improve in their overall sporting performance due to the reasons stated. In addition to VO2 max, these aerobic adaptations could also benefit general health as well as just sporting and event performance. For example, an aerobic adaptation due to persistent exercise and training in this way could reduce the risk of coronary heart disease. This is due to the fact that the heart will not be clogged if a person aerobically exercises often, and also blood will be less viscous and less able to cause a blockage in the heart. This therefore massively decreases the risk of heart attacks and coronary heart disease, and is another positive effect that comes from these aerobic bodily adaptations, as these will not only just benefit sport performance but also general health. CV system adaptations. In terms of the CV system in aerobic exercise, there are many different adaptations that will occur to this system in order to improve overall sports and event performance, and also general health. Firstly, the muscular wall of the myocardium would become thicker and stronger as a result of consistent and often aerobic exercise. As well as this, the myocardium itself would increase in size, which is known as cardiac hypertrophy. Both of these adaptations would cause stroke volume to increase. This can be seen in the graph above. As you can see, the untrained stroke volume stays the same starting and finishing on 120 milliliters. The trained line, as you can see here, clearly shows an increase from 138 to 196 milliliters. This evidence from the graph shows us that the adaptation is relevant to training, as will occur very significantly, as the example of the increase by 58 milliliters in the graph shows us. These adaptations would also mean that a person would therefore have a lower resting heart rate as stroke volume has increased, meaning more blood will be ejected from the heart per beat, and it will therefore not have to beat as often. A lower resting heart rate will show an increase in fitness, as this is something measured to see if adaptations have taken place and to see improvements in fitness. These adaptations would also result in an increased cardiac output, which would also show fitness and performance improvements have been made, as these are easily measurable and noticeable adaptations to occur due to aerobic exercise. In addition, another adaptation that would occur to the CV system due to aerobic exercise would be an increase in heart rate range. Heart rate range is the difference in the number of beats per minute your heart from your resting heart rate to your max heart rate. Therefore, this heart rate range would increase due to the fact that resting heart rate decreases. This means that there is a greater gap between resting and max heart rate, if resting has gotten lower, and therefore increasing heart rate range. This is useful for a performer or games player, as this would mean that they have a larger capacity to work through, and can increase at a higher capacity and can increase by more beats per minute than before, as they are now further from their max heart rate. Therefore meaning that they would be more successful and efficient in their sport/event. Another adaptation that would occur is known as capillarization. This is where an adaptation of aerobic exercise, the amount of capillaries and density of these capillaries will increase. This will cause a larger surface area for diffusion to occur at the muscles. This means that more gas exchange can happen at a faster rate in the muscles, providing the muscles with more oxygen and removing waste such as CO2 faster. This would cause a performer/sports person to improve, as they can get more oxygen to their muscles quicker, as well as also expel waste from the body faster. Furthermore, another adaptation that would occur would be there would be a greater volume of blood in the body. This will mean that there is an increase in the amount of red blood cells in the body. Stimulants will transport these red blood cells to the muscles, meaning there will be more oxygenated blood in the muscles, which will mean they are able to successfully work for longer and be more efficiently working, as there is more blood in these muscles even after the redistribution of blood and vascular shunting have taken place to cool the body. This increase in red blood cells will also cause blood to become less viscous, which is the reason for the risk of coronary heart disease to decrease due to these adaptations that not only benefit sports but also general health. In terms of aerobic sports and events, these CV adaptations to aerobic exercise would cause improvements of both of these. For example, a marathon runner would be able to run for longer periods of time, as well as supply the working muscles with more oxygenated blood and get rid of waste quicker, meaning they would be able to sustain a faster pace when running this event due to the adaptations listed. A footballer would benefit for these reasons as well, as they would be able to run for longer, meaning they could sustain a higher work rate throughout the game and would therefore give them an edge on opponents. CV graph analysis. The graph above shows heart rate before, during and after 20-minute steady-state exercise. The graph next to this shows what the results would look like after long-term aerobic training has taken place. As you can see, the first graph shows a resting heart rate of 62, whereas the graph after training shows this lower value of 56. Differences like these are also relevant in the pre-test, 10-minute and post-test readings. These show differences from 6 lower at the pre-test from 80 on this graph to 74 on this graph. 4 lower at the 10-minute mark from 82 on this graph to 78 on this graph. And finally 8 lower on the post-test from 98 here to the after training value of 90. These differences in heart rate show that aerobic adaptations have taken place in the CV system. This is apparent as the graph after training shows lower heart rate values, which also shows that therefore stroke volume must have increased, meaning that the heart will have to beat less to provide the working muscles with this oxygenated blood. This lower stroke volume would be a result of the increased strength and size of the myocardium due to muscular hypertrophy. The graphs therefore show evidence as to the significance of these adaptations on improving factors to do with the cardiovascular system and would cause major improvements in both games players, for example a footballer, or an athlete, for example a marathon runner. These adaptations could also mean performers could increase scores in fitness tests such as the multi-stage fitness test.